long duration energy storage, and to promote different capacities, different technologies, different geographies. And so we're looking forward to 2 presentations today from ENERGYNEST in Kyoto, and to also have your questions. So please use the Q&A, and we will make sure. Again, thank you so much all for joining us today. We look forward to the conversation. The next slide, just want to give you a little bit of quick background about the council. As we're all experiencing, there's just been constant reminders, seasonally about the climate changes with droughts, wildfires, extreme heat, cold, and just how important it is for us to meet our global net zero targets. And because we need so much more flexibility, because of the need for meeting clean energy goals with wind and solar, we need to make sure that every hour of every day is met with clean energy, and you can provide that flexibility with long duration energy storage. And so what the council is doing is really trying to promote the market sector and really demonstrate to all the industry sectors and the economy that the critical role of long duration energy stability, the affordability, and reliability. And as you've seen in the last few months, just the enormous amount of support for long duration energy storage, just the $26 billion being invested in the marketplace, really again highlighting the need and the awareness of the important role that long duration energy storage can provide. And this is a little bit more about our organization. We were launched at COP26 with our flagship report, Net Zero Power, focusing on what's now $4 trillion market long duration energy storage that's needed to meet our global net zero targets. And the members of the council really provided a really unique ecosystem where you're bringing together diversity of technology providers, looking at the 4 different types of long duration energy storage. So thermal, mechanical, chemical, and electrochemical. And then also providing the customers, the capital providers, the developers, the manufacturers to all come together to validate and really promote the marketplace for long duration energy storage. We're doing the data so we can change the policies to create the marketplace, and doing this for societal benefit, so we have the decrease in emissions and the health benefits. And so just a bit more on the technology providers. Today we're really excited to hear 2 different types of thermal energy storage. So we're looking at ENERGYNEST with sensible heats, and we're looking at Kyoto with sensible heat solids and liquids. And so again, looking at the diversity with each of these categories of what's available, whether it's small, large scale, behind the meter, utility scale, whether it's underground, above ground, containers, geographies. It's just really important that we have this diversity to meet our local community needs. Whether you're in remote systems, islands, urban centers, you need to make sure that you have an awareness of the diversity of long duration energy storage. So this is another benefit of the council, really promoting the great work and the marketplace that's available to the different technologies. So I just want to thank our 2 members for taking the time today to dive a little deeper into the important role of long duration energy storage. So I'm going to hand it over to Kyoto, to Bjarke, to talk more about what he's working on in thermal energy storage. So thank you both again.
Thank you very much, Julia. I have a small presentation for you here, and thank you very much for letting me speak today. So we have made a thermal battery. We call it the Heat Cube, and it is a thermal battery for the industry. A little bit about the road that we're here. We're a fairly young company, funded back in 2016, and around 2020 started really to focus in on thermal energy storage. And through the last couple of years, we have developed our product, which we are now commercializing on the market. Why are we doing this? So basically, half of the world's energy consumption is, and half of that is industrial processes. If you take that into the picture of CO2 emission, the 25% of the industrial processes accounts for approximately 40% of the global CO2 emissions, and we're here to decarbonize that. So how do you do that? Yeah, one of the things that you could do is, of course, electrify the industry. So, and that is is a good thing, because then we can remove all the fossil fuels that we are currently using to generate heat in industry. But what happens then is that we replace, you could say, a fast response energy source with an unstable source of energy, which could be solar or wind. And that gives an unmatched demand versus what we can deliver to the grid. And in order to match that, you need storage. You need a thermal battery if you want to produce heat. So basically what we have developed, it's a flexible energy storage system that is able to deliver heat on demand. It can discharge in form of steam. It can also potentially discharge in hot air or the liquid if that is needed. We generate the heat while the energy is cheap, and then we can dispatch it whenever the customer needs it. We're using non-flammable, non-toxic materials that replaces oil, gas, and diesel burners in industry. We have an on-site installation connecting to existing infrastructure, so there is very little influence on the customer sites here. So that is our product. A little bit about how it works. So it is, as Julia said, it is a system based on molten salts. We're using a ternary salt, and basically it's a hydraulic system where you pump the liquid from the tanks. Now you see the cold tank being pumped into an electrical heater. The electrical heater heats up the salt to a high temperature, and when we want to discharge the thermal battery, we run it through a steam generator. So it is pretty simple. We charge with electrical heater and discharge with the steam generator. And this can be done completely independent of each other. So whenever you want to charge, you can charge. Whenever you want to discharge, you can discharge. And that is start and stop is completely, the charge and discharge is completely disconnected to each other. So you can operate whenever you need. And that enables us to deliver 24/7 to the customer. It enables us also to take up energy whenever the price is low. So our technology comes from quite proven technology. It's pretty much, we have taken the thermal storage that has been developed for concentrated solar power, and we have taken that, and as you can see here, the system is quite large, but we have scaled it down and made it more simple and more robust. Basically, this technology has been existing for the last 15-20 years, and our engineers are from this business and have taken this into our setting. So we are using a quite proven technology with a proven supply chain. As you can see here, this is actually, we have only taken a specific part of the CSP technology. We are only taking the storage part. But what we have done, CSP projects and designs, there is an engineering, it's an engineering process from scratch. It's an EPC project, basically. But what we have done is that we have taken the technology, we have standardized it, we have modularized it and made it scalable so that it fits the different requirements of the customers. Here is a small video showing you a little bit around at Heatcube. Basically, what you see is that we have storage tanks. It's the vertical tanks that you see standing in the background. They are filled with molten salt, except one of them. In the front, you see on the right side, you see a steam generator, and on the left side, you see our electrical heaters. The salt is pumped around in a hydraulic system connected with pipelines, which of course is insulated and controlled by a battery management system. Our unit is quite energy dense. We can store between 16 to 96 megawatt hours in our facility. It's depending on how many tanks you are placing there. Our heaters can be scaled from 10 megawatts up to 30 megawatts, depending on the need. On the discharge side, we have around 5 megawatts up to 5 megawatts of discharge in terms of steam. Here we can do both saturated and superheated steam. Our product, as it says in the end of this presentation, basically consists of steel and salt, and it produces steam. That is the 3 S's. Here is a little bit about the key features of our system. As said before, charging capacity can be scaled to the need of the customer, 10, 20, or 30 megawatt electrical. That then goes into thermal. The storage capacity is depending on how many tanks you put together, so between 16 and 96 megawatt. And discharge capacity is up to 5 megawatt. With discharge in form of steam, it can both be superheated and saturated steam, and the temperature ranges of our steam is between 170 to 400 degrees. Our salt temperature is 115 degrees, and the footprint is around 250 square meters, up to 310. The height is approximately 8 meters, and the weight is between 400 to 1,500 metric tons. The key benefits of our system is, of course, that we replace predictable low-cost electrical source. It is completely customizable and scalable to the need of individual customer, and it can deliver constant temperature and pressure. Because of us using liquid, it has very, very good quality of steam, and we can ensure that the steam temperature and the steam pressure stays very, very stable throughout the discharge period of the battery. It is a proven technology, also meaning that we have quite good knowledge and quite good, you can say, training around operation and maintenance. And we are designing this with a lifetime for more than 25 years of production of steam. Our round-trip efficiency is 90% or more. And we have a thermal loss of our system of approximately 1% per day. It is a very environmental friendly solution because the steel that we have can completely be reused. It's a recyclable product. The same goes with the salt. The salt in the end of operation can either be used for another thermal battery, or it can be used as a fertilizer, because that is basically what it is. It's nitrate salts that is used for fertilizers. It is safe, non-flammable, and no ATEX certification is required. We can charge and discharge extremely fast, potentially down to less than 1 minute in startup time for both charge and discharging. And that is pretty much the key features of our products. Thank you very much.
I always love learning from our members. There's always something new in their presentations, and hearing about the ways to recycle steel and the sustainability footprint is great. And seeing the SDG goals down below is for our guests to add more questions to the Q&A button. I have a couple to ask you. So on the cylinders, are they insulated? Is that what, or is there, what kind of insulation are you using so that you decrease the loss?
So it's normal insulation, cheap materials, cheap robust materials. It's mineral wool based. So yes, insulated and traced, of course.
And then when you mentioned the height at 18 meters and the cylinders for 96 megawatt hours, do you have to add additional cylinders, or the stack you showed
that we showed contains of 8, so that was a 56 megawatt hour battery. If you wanted to go to 96, you of course just add more. You just add more tanks. It does not do anything to the system than just adding more tanks. So the footprint is going to increase, but that's it.
Great. And we have some questions coming in. So how long does it typically take from the first design to commissioning?
We are targeting down to between 6 to 9 months from contract sign to commissioning. And this is the reasoning behind this is that we are using standardized components. So we are not an EPC company, but we deliver a product that can be fitted to the requirement of the customer. That enables us to deliver it also fast.
And then do you need to maintain the molten salt above certain temperatures when the system is idle?
Yes, that is we do that. So I mentioned that very fast, but in contrary to normal CSP business, where you use a binary salt, we use a ternary salt, and that enables us to. The salt has a very good feature is that it has a quite low freezing point, and with the molten salts, our freezing point is around 131, whereas a normal binary salt is maybe around 220. So we have much more margin in terms of lowering the temperature before we get freezing inside. But yes, we have to maintain the temperature while it's not running.
Great question, great points. And so there's more coming in. So thank you for your presentation. So on the round trip efficiency, is electricity to electricity, is it 90% efficiency mentioned only electricity to heat? Or do you need to account for the steam turbine efficiency, which might be 40 to 45%?
So what you would do, what we say is that if you need heat, then store it in heat. If you need electricity, store it in electricity. So that is kind of a little bit a mantra that we have developed. And if you go from electricity into heat, the conversion between those things is extremely efficient. So this is from electricity into heat. Into electricity, you of course have to take into consideration the efficiency of your steam cycle. So it depends on which one you use, but in our system, the efficiency would maybe be between 20 to 25%.
Couple more. Temperature and adding a power output method to also supply electricity. And what would the limit be to potentially electric heater limits?
So we have that is for sure something that we are considering, and it's also something that is very possible. It is possible simply to add a steam cycle to our steam generator, and then create electricity and heat combined. That is for sure. So it is something that we are considering. Yes.
And then how do you mitigate solidification of the salts during operation, and how do you handle the salts during maintenance of the system?
Yes, so this is a little bit, I think it's a little bit the same question as before, but just a comment to that. We have the ternary salt, which is very nice in terms of the low freezing point. So we are not struggling as much with the freezing as the salt, but of course the full system is traced. And another thing is that this design of our system, it might not look that complex or you could say or sophisticated, but it is quite well thought through. And one of the features is that it is automatically drainable, meaning that if we have a shot that prevents salt from freezing in our system, the only place you're going to have salt is in our drain tank and in our storage tanks, and that will not solidify that fast. If you have 1% of heat loss and your salt is 200 or 200 around 200 degrees, you will have some weeks before you have problems.
Great point. A couple more questions, then I want to make sure we get to Christopher too. So how do you scale the input and output power level, parallel or scaling of the steamers and heaters?
So right now, the question about the power output, you will then need a bigger steam generator. So you will have to input a bigger steam generator to get a higher output out of your electricity. So that is also something that we're looking into. So simply making a bigger steam turbine with a superheater on top, so we get the superheated steam out at a high temperature that then can run into a steam cycle, steam turbine cycle. So you have to scale it to the need, of course, that you have of the customer. If we go into these kind of projects, it is no longer It is no longer something that we have of standardized component, but it is not something that we cannot supply.
And here's a question on why don't you use concentrated solar thermal and directly use the heat instead of electric heater?
It's also a very good idea. It's a very good idea. The thing is that if you want to do the concentrated solar power, it requires quite a lot of space, and it's not everyone who has that space available. But if you do, I think it is interesting, and I know that there's many companies who looks into either solar collectors or also small solar towers that we might might be interesting to work together with.
Okay, last question, and we're going to go to Christopher, but there's a couple more we'll answer offline. So this is, who are your key?
But the pulp and paper industry is extremely interesting from our side. Very, very interesting. Basically, everywhere where you have an existing steam infrastructure, non-ferrous materials, mining, yeah, you name it.
Thank you so much, Bjarke, for your great presentation and for answering the questions. And thank you again for all the work that Kyoto is doing and for the work that you're doing with the council. We appreciate it. So great insights, and we'll continue the dialogue and conversation. And now I'm going to hand it over to Christopher.
Thank you, Julia. I'm going to share this. Can you see the presentation?
Not yet.
Are you able to see the presentation?
Nope. Mm-mm.
Okay. Let's go back. Now.
Voila. Yes.
Good. Great. Thank you. Thank you for inviting me also. So I'm going to present ENERGYNEST and our technology. In short, we have developed a technology that's based on storing thermal energy in a solid state castable concrete-like material that we call heatcrete. On this picture, you see actually a construction of one of our projects, which I'll also go into more detail later. But first, a few points about ENERGYNEST. So here you see our great team. We are almost 40 people now and also growing. We started in 2011, and we started off as a pure Norwegian company, but we have now grown into a truly European company. We're 10 nationalities, and we have offices outside Norway. We have offices in Germany and also in Spain. And last year, in 2021, we signed a record-breaking investment deal with Infra Capital of more than 100 million euros, and they are now our majority shareholder. And they also provide a very strong financial backing, not just for the company, but also to roll out projects. On the technology side, we had our first prototype validated in 2013. Then we went on to build and operate a pilot in Abu Dhabi, which was decommissioned in 2017, very successful results. And then we received our first commercial order in 2019. And currently we have one commercial demonstrator in operation, and we have 2 more under construction. So the core technology is essentially a modularized system using special concrete that we call heatcrete. So we have 7 patents around the system design, covering everything from the core elements, that we call them, to the modules and to how you configure systems and operate them. So if we start with the heatcrete, so this is not a normal concrete. This is a tailor-made thermal concrete that has been developed together with Heidelberg Materials, and they are fabricating and supplying this material. So it's chemically stable up to 450 degrees Celsius, and it retains its very high compressive strength beyond 90 megapascals, even after 500,000 load cycles. It has a very high thermal conductivity and a high heat capacity. And also it has a thermal expansion, which is very similar to that of steel. And when we look at the pictures, we see what we call the thermal battery module. And this consists of essentially two parts, steel and heatcrete. It's a steel frame designed as a 20-foot shipping container. And inside this frame, we have cylindrical thermal elements that consist of the heatcrete and cast-in steel pipe heat exchangers. In a way, it's like a shell and tube heat exchanger where you have the heatcrete on the shell side. So it's a very simple, very robust, long duration storage. There's no maintenance required on the module itself, and it's all welded steel piping. It has a design temperature up to 400 degrees Celsius and a lifetime that can exceed 30 years. There's no performance degradation over the life, and as I mentioned, there's also no maintenance required on the core technology. And the way it's designed allows it to be handled and transported as a normal 20-foot shipping container. And quite important is that we can use different heat transfer fluids to charge and discharge our battery. Notably, we can use water steam directly inside the pipes, and we can use thermal oils, and we can in principle also use compressed gases. And the way we construct a storage is also very simple. We have a concrete foundation with load-bearing elements, as you see on the left side. This picture is taken from our project with Yara in Norway, which is currently in operation. On the left side picture, you see a stack of 4. They are hydraulically connected in the vertical direction. And when you charge the battery, we have hot fluid entering at the top, and then cold fluid coming out at the bottom. And then when we discharge, we reverse the flow. And as I said before, we can use water, steam, thermal oils, or also other fluids. In the middle picture, you see the insulation works. We use standard industrial mineral wool insulation. And on the right side, you see the complete facility. It's a simple steel structure with a steel cladding, piping interface, control system, instrumentation, and integrating into the customer's process. And the technology is fully scalable because we can do anything from a few modules up to hundreds or even thousands of modules. It's just about adding more stacks and connecting them with the same piping system. So the fact that we can operate with water, steam, and thermal oils gives our technology a high versatility. And that means we can do power to heat, which is clearly the most or the biggest focus in this LDS council. In this setting, we take renewable electricity from the grid or from local resources, and we convert process heat or typically process steam. And in the case of direct steam, we can charge with standard electric steam boilers, or if we use thermal oil, we use thermal oil heaters. We also have many applications within. So here we can integrate our storage into concentrated solar thermal plants to provide heat to local industries. We can also integrate with concentrating solar power plants, either retrofit, being part of new build plants. With a direct steam solution, we can directly integrate into industrial steam networks and provide balancing of steam demand and supply, reduce volatility, charge with other. Technically, we can do also the same by integrating into steam electric thermal power plants, and by that provide additional flexibility on the power production. And last but not least, we can also recover otherwise wasted heat from industrial processes, typically via thermal oil heat exchanger. And then we can convert that heat into usable process heat, or typically process steam. And in the last category, heat to power, we do something very similar. We do waste heat recovery, but we can convert that heat rather into electricity, for instance, using organic Rankine cycles, either producing pure electricity or in combined heat and power mode, supplying also hot water for district heating. Some more details on our commercial demonstrators. On the left side, again, this is the plant we have in operation with Yara in Norway. This is a direct steam solution connected to their steam network. And here we are balancing fluctuation network at 34 bar with excess steam, and then discharging to the low pressure steam network at energy efficiency and reduces fluctuations in the steam network. In this system, we have 4 modules combined with a pressure vessel. We also have our own patented design for the functionality of the steam solution. And in this small plant, which is relatively small, it's only 4 modules, we have approximately 3.5 megawatt hours, but we can discharge at the power up to as much as 3 megawatts. And this is for short-term load fluctuations in the steam network. You see that we have designed this for 200,000 hours of operation and almost 500,000 cycles. On the right side, you see the project we have for concentrated solar thermal. Here our battery is integrated with a solar field in a plant which is under construction in Belgium. This solar field operates with thermal oil, and we charge the battery then with hot thermal oil up to 380 degrees. And we discharge thermal oil back to a heat exchanger, which provides a different thermal oil to a nearby factory owned by Avery Dennison. So the battery here has a capacity of 5 megawatt hours and a charge and discharge capacity up to 1.5 megawatt. And also here the design life is 25 years. The third project, which I'm not shown in detail, is with Eni, the Italian oil and gas company, which is in Sicily, small scale CSP project with 1.5 megawatt hour battery, also operating with thermal oil. We are also involved in development of large projects. This is a rendering of how a CSP retrofit project could look like. And here we have about 200 modules and with a total storage capacity of around 300 megawatt hours. So to summarize the main features of our technology. In terms of energy, we can do anything from a few megawatt hours up to gigawatt hours. On the power side, we can do anything from below 1 megawatt and up to hundreds of megawatt. And in the case of steam, we can charge with pressures up to 100 bar. We can discharge at temperatures up to 350 degrees Celsius. And in the case of steam, we can discharge at pressures up to around 60 bar. Our response time is governed by control system, opening of control valves, ramping of pumps. So it's in the order of seconds to minutes. And we typically design our systems for lifetimes of 25 to 30 years. And there's no performance degradation over time. The round-trip thermal efficiency of the battery depends largely on the size. The bigger, the lower the losses, and also it depends on the operating temperature and the insulation properties, but typically in the range of 95 to 98%. And we can operate with different fluids, including water, steam, thermal oils, and also other compressed gases. And in terms of technical maturity, we are steadily approaching the highest levels, 8 or 9. And then last but not least, a bit of a sales pitch. So we offer full system solutions, including the energy conversion and also the storage. And finance solutions with long-term service contracts, also known as heat as a service. Thank you.
Thank you, Christopher, so much. It's great to see, the two technologies and the diversity and the innovations that are occurring to really kind of provide the scale that you're both highlighting. And Christopher, I have a couple of questions while we're letting our participants add to the Q&A. So what's the height of what we're looking at right here, and whether it's the 4 cylinders or 6 cylinders?
Yeah, the height is quite flexible. So one module is the height of a container, which is 2.4 meters. So here we see a stack of 4 modules. Height is approximately 10 meters, but we can do 2 modules, 3 modules, up to 5 modules high. So we are quite flexible on the height.
And then can you speak more about charging and discharging, about the time it takes, whether you're using steam or thermal oil?
Yeah, so to get a good energy density, we typically charge, let's say, 3 to 4 hours or more, and the same for discharge. But it's fully possible to operate in a much shorter time scales, and that's also the reason why we have 500,000 cycles as design, is that in this system we can charge and discharge to balance load fluctuations, which are in the order of 5 minutes. So it's possible to do anything from minutes and up to.
Yes, I wanted to hear the days part too, because I think that's a big benefit of thermal energy storage. It's just the continuity over multiple days too. And so here are some questions coming in. Why do you need the cylindrical steel encasing the heat creep? Can it work without the outer steel shell?
Well, that steel cylinder acts as a permanent casting form. It's also a ring reinforcement, so it has many benefits. It would complicate the construction or fabrication process of the module if you would not have this steel cylinder.
Sorry, with thermal storage material, do you have operational limitations where you have to fully charge and discharge the battery for adequate performance?
No, we can charge partly, discharge. We can fluctuations on let's say balancing the heat source and the heat sink. So there's really no limitations on that.
And what about the steel? And where are you getting the steel from and where are your factories to make the cylinders?
So also a beauty here is that what we're looking at here is essentially carbon steel frame with carbon steel pipes. So this can be fabricated by a lot of companies. We have several companies that are qualified. We have been doing fabrication so far in Europe with a Dutch company, but that has fabrication in Romania and the Czech Republic. But in principle, this is something that can be fabricated all around the world. And of course, once we scale, we will also source this from other places.
I'd like to ask actually both of you, like, what do you see as the current challenge to really scaling up? I mean, you have customers, but what else do we need to ensure that we're scaling?
Well, I think, the market itself is, but it's still a bit in its infancy. So I think, the market pull, which we are seeing a massive increase of that in the last year. So I think that we're sort of really in the start to see this happening. So I think with market pull will also come scaling.
And you both highlighted the diversity of customers that you can work with, whether it's providing the steam or heat or the clean electricity. This kind of opportunity of what's available for various industries, I think, is really important. So, if Bjarke, is there anything else you want to add to the challenges to the marketplace? Might have said to it. Okay. Well, so are there any other questions from the audience too? Want to make sure that we're giving you all ample time to ask the really good technological questions you have. Yes, go ahead. I was asking both of you if you want to answer about the challenges and the barriers to the customers in the marketplace. So, we were talking about how the marketplace is, there's so much opportunity for so many industries, but are there any, specific balance obstacles that you see for Kyoto, just like we heard for ENERGYNEST?
Yes, of course, there is barriers. One of the barriers is of course that you have to get a new type of technology into an existing facility. You're used to having a complete infrastructure of having the fossil fuels, which is easily on-demand heat. So there is of course from my side.
It's great to hear both your perspectives too, and also kind of the stages of where you are. And again, the innovations diversity that's so important. So this is for you, Christopher, how much of an obstacle is the integration of the thermal battery into existing industrial processes?
This is not really very challenging, because we use process equipment and fluids that customers already have at site or are familiar with. So with the direct steam solution, we are not really adding any new complexity. I mean, we're using the same components, instruments, valves, pumps, etc., that they already have in their steam system. So it doesn't really require any let's say special operational maintenance. And with thermal oil, that's also a very commonly used heat transfer fluid. So in our sake, that is really not the issue.
So we're getting close to our time, and again, I want to thank everyone. What's the one message you both want to leave with our guests today about what you want them to take away about thermal energy storage in your companies?
From my side, it is that it's ready, it is there for you, and I believe that it can give you a pretty big benefit in the decarbonization of your industry.
Great.
That's very well said, and I will say the same.
It's that collaboration we have to really promote the importance. So again, thank you both so much. It is true, long duration energy storage is here. We have technologies that are available. We're in the market, and we need to continue to scale up, and we can address and meet needs of diverse customers more. And we'll talk to you all soon. Thanks so much.
Thank you.
Thank you.
Thanks.
Bye-bye.
Ciao. Bye.
Bye-bye.